Hello everyone, you are welcome. How to solve this nice algebra math problem, which is k by 5 times k by 5 is equal to 5 by k times 5 by k. So here we will try to find out the value of k from this nice algebra math problem. So what we'll do here? Here on the left hand side we will multiply numerator with numerator and denominator with denominator. And in the same way in the right hand side we will multiply numerator with numerator and denominator with denominator. So this equation will become implies here k times k is k square divided by 5 times 5 is 5 square is equal to, this will become 5 times 5 is 5 square and k times k is k square. Now we will cross multiply these two numbers. So this will become, you will multiply k square with k square and 5 square with 5 square. So from here we will get k square times k square is equal to 5 square times 5 square. Now here same number is multiplied 2 times in both sides of this equation. So we can write this as k square whole square because this number is 2 times. And the same way we can write 5 square whole square. Now here we will move this number to the left hand side. So this will become negative 5 square whole square. And this equation will become implies k square whole square minus this will become 5 square whole square is equal to 0. Now here in both the term there is square. So here we will use the negative algebraic identity, a square minus b square identity. So here in this step we will use this one algebraic identity, a square minus b square, which is equal to a minus b times a plus b. So here a is k square and b is 5 square. So using this identity, here we can write this equation as, this implies this will become k square minus 5 square times k square plus 5 square is equal to 0. Here the product of these two quadratic equation is 0. So here either this quadratic equation will be 0 or this quadratic equation will be 0. So from here we will get two equations. The first equation is k square minus 5 square is equal to 0. And the second equation is k square plus 5 square is equal to 0. Now here first we will solve this equation. So we will move this negative 5 to the right hand side. So it will become positive 5. So k square is equal to 5 square. We will take square root on both sides. So this will become, here this square and this square root will be cancelled. So only k will be left here is equal to, and here this will become square and square will be cancelled. So this will become plus minus 5. So here we have two possible values of k. Let us suppose k1 is equal to plus 5 and k2 is equal to negative 5. Then we will try to solve this one quadratic equation. So again we will move this positive 5 square to the right hand side. So it will become negative 5 square. And this will become k square is equal to negative 5 square. Now let us take square root on both sides again. So this square and square root will be cancelled. So only k will be left here. And here we can write this as plus minus square root of negative 5 square can be written as 5 square times negative 1. Here we will split this square root over 5 square and negative 1. So this will become plus minus square root of 5 square times square root of negative 1. So further it will become plus minus, this is 5, and we know that square root of negative 1 is a complex identity which is equal to iota. So we replace it with iota. So here we have two complex values of k. Now let us suppose k3 is equal to plus 5 iota and k4 is equal to negative 5 iota. So finally we have 4 possible solutions and 4 values of k. 2 are real, plus 5, minus 5, and 2 are complex, plus 5 iota, negative 5 iota. Here we will try to verify these values, as these values are exact, correct or not. So we will check out these values here. Let's first check out the value k is equal to plus 5. So k is equal to plus 5. Now what is the equation? The equation is k by 5 times k by 5 is equal to 5 by k times 5 by k. Now let us replace k with 5. So this will become, this implies this will become 5 by 5 times 5 by 5 is equal to 5 by 5 times 5 by 5. So here we can cancel these numbers with each other. So there only one will be left in both sides. There is 1, there is also 1. So 1 times 1 is 1 is equal to, here is 1, so there is also 1. So 1 times 1 is 1. Now since both sides are equal, so it means that k is equal to 5 is exact and correct value. Now if we try to replace k with negative 5 and we will check out that value. So let's replace k is equal to negative 5. So let's replace here k with negative 5. So this will become negative 5 by 5 times negative 5 by 5 is equal to 5 divided by negative 5 times 5 divided by negative 5. So again we will cancel this 5 with this 5 and this 5 with this 5. So in the same way, in the right hand side, this 5 will be cancelled with this 5 and this 5 will be cancelled with this 5. So here minus 1 is left times, here is also minus 1 is left, and here there is 1 over minus 1 times 1 over minus 1. Here negative 1 times, as we know that negative times negative is positive. This is a math rule. Negative times negative is always positive. So this is positive 1. And here we know that 1 divided by negative 1 is always negative 1. So this will become negative 1 times negative 1. So 1 is equal to, again negative 1 times negative 1 is positive 1. Again, since both sides are equal, so it means that k is equal to negative 5 is also the exact and correct value. Now here we will try to verify the complex values. Now the complex values are, the first complex value is 5 iota. So let's replace k with this value. So this become 5 iota divided by 5 times 5 iota divided by 5 is equal to 5 divided by 5 iota times 5 by 5 iota. Now here we can cancel this 5 with this 5 and this 5 with this 5, this 5 with this and this with this. So this will become iota times iota is equal to, and this will become 1 by iota times 1 by iota. So iota times iota is iota square, I square is equal to, and here 1 times 1 is 1 and I times I is I square. Now we know that I square is equal to negative 1. So here we will replace I square with negative 1. So this will become negative 1 is equal to, and this will become 1 by negative 1. Now as we know that 1 divided by negative 1 is equal to negative 1. So this will become negative 1 is equal to negative 1. So here we can cancel negative sign with negative sign, or we can multiply both sides by negative sign or negative 1. So let's cancel this negative with this negative. So this will become 1 is equal to 1. Now since both sides are again equal, so it means that k3 is equal to plus 5 iota is also the exact and correct value. Now in last we will verify the fourth value, that is minus 5 iota. So let's check out k is equal to k4 is equal to negative 5 iota. So again we will replace k with its value, so this will become negative 5 iota divided by 5 times negative 5 iota divided by 5 is equal to 5 divided by negative 5 iota times 5 divided by negative 5 iota. Let's cancel 5 with 5, so this will become, here only negative iota times negative iota are left, and here only 1 by negative iota times 1 by negative iota is left. Now we know that negative times negative is positive, so this will become positive, and I times I is I square is equal to, and 1 times 1 is 1, negative times negative is positive, and I times I is I square. Now let us replace I square with its value, that is negative 1, as we know that I square is equal to negative 1. So here we will replace I square with negative 1, so this will become negative 1 is equal to 1 by negative 1. Now here we can multiply both sides by negative 1, so this will become negative times negative is positive, and 1 times 1 is 1 is equal to, and this negative 1 and this negative 1 will be cancelled, so only 1 is left. Now since both sides are equal, so it means that k is equal to minus 5 iota is also the exact and correct value of k. Now in last, as we verified that k is equal to plus 5 and k is equal to minus 5, and the complex values that are 5 iota and minus 5 iota are the exact and correct values and solutions of this nice and interesting algebraic math problem. Now in last, if you like this video, so don't forget to subscribe my YouTube channel for such a more interesting and step-by-step math videos. Thanks for watching.